So augmented matrix and REF. REF stands for row echelon form. Now the process here is manual, and as I said, I'll introduce you to the concept, but use the calculator. I'll show you how. So REF stands for row echelon form. What is row echelon? Well, row echelon is of a matrix. Is any matrix. I'll take 2 by 2 first. Where you have ones in the diagonal, and you have some number of them. Good. In the 3 by 3 case, have 1, 1, 1 diagonal. Some number, but 0 done. Good. Yes. No, any thoughts in the 4 by 4 case? That's the 2 by 2 case. 3 by 3 case. I can put it in words, but if you can't see it, understand it better. So what should go along the diagonal? Ones. How many of them parted? 4. So 1, 1, 1, 1. So how many zeros should go down here? 3. So 3 rows. Next. 2. Next. 1. And over there, you could have any number. You can extend this to 5 by 5, 10 by 10, 20 by 10. It doesn't matter. Why is this important? Well, the calculator doesn't magically do a inverse. There is a process behind it. One of those many processes is to obtain the row echelon form. Why is this important? Well, I'm going to take matrix A. In my first example, it was 1, 1, 3, 2 in my right, the 2 by 2 case. And the right hand side was 5 and 14. Yes? What does augmentation mean?
Enhancement. Enhancement. Augmenting.
Louder.
Enhancing something.
Augmenting is enhancing. That's an English word. Augments something. Change. Okay. Combine. Augment means you're combining things. So, or appending something, which is a form of change, right? But the correct explanation or meaning would be combine. So an augmented matrix for our system is that. Now, we are going to do this manually, just for the 2 by 2 case, but what are you supposed to do when you do that homework? Use the louder
Calculator.
calculator. Okay. So this is what we call the augmented matrix. And what we will do is to take this matrix and we would perform a series of row operations. When you do those row, you have to do the row operations in such a way that this matrix turns into something like this. Some number, 0, 1, some number, some number. Yes? So we take that matrix, we're going to do a bunch of operations to get in that form. What is the advantage of this form? This will equal that number, correct? In other words, when you do this part, you pretty much found the solution to y. Yes. And you're going to take that value of y, plug it back in here, you will get a solution to x. Good? So pretty much what you did in algebra, you know, by eliminating, substituting, is carried out here using matrices. That's why I say that this is also, you know, manual, it's intensive. Good. The reason why I'm going to show you the concept is because it's still used, and I'm sure when you take linear algebra or matrix algebra, they will make you do it. Good. This is important. Good. Okay. This process define the solution to the linear system is called Gaussian elimination. There is another case which is Gauss-Jordan elimination. I will touch on both of those. I'll introduce you to them, but use the calculator. Unless you want this stuff. Are we clear?